Welcome back. Today we are actually going to talk about how to find missing values or missing parts of similar triangles. So to do that, I made this a little while back. If you could tell, I hand drew most of these examples. So I want us to be able to set up and solve to find some missing parts. I'm going to do a few with you, and then I'm going to ask that you complete the rest on your own. So let's take a look at this first example. The most important part is being able to recognize what is similar. And sometimes you have to use the markings to do that because in this example, they don't write a statement for you. So if you see how this is a congruent angle and this is a congruent angle, that means that 9 corresponds with x because they're both opposite that angle. And then the other two sides are very easy to figure out what corresponds because you pick the smaller of the two, which here is 15, and that should correspond with the smaller of the two here, which is 20. And then you know that 18 corresponds with 24. So if you have all three sides, you could actually write all three ratios. Now remember, stay consistent. So I like to go from left to right in this example. So I'm going to say 9 over x will equal, or should equal since they're similar, 15 over 20, which also should equal 18 over 24. So notice that's the initial step. Now, if I want to solve for x, I only need two of these ratios. Obviously, one of the two that I want to use is the one that has 9 over x because I need to do the math that can solve for x. Now, does it matter if I use the 15 over 20 or if I use the 18 over 24? Well, it shouldn't, and it doesn't. When I put 15 over 20 in my calculator, I get 0.75, or 3/4. When I put 18 over 24 in my calculator, I also get 0.75. So really, it's up to you what you want to choose. So I'm going to choose 15 over 20 because, you know what, why not? And then from here, I can cross multiply. And then 180 divided by 15 is 12. So I get 12. And there you go. That's how you find a missing part of similar triangles. So again, in the directions, all I told you is that the following triangles are similar, and you have to solve for the missing parts. Now it gets a little bit trickier when you look at B. Now why is that? So I have to recognize here's an open arc with this open arc. So opposite that open arc is a 7 here, and opposite that open arc here is the X. You needed to catch that from the beginning because if you don't, you'll mix up the wrong parts. Some people like to redraw the triangles and make it match. So like some people like to draw them on the side. So you might want to get some scrap paper. Now here's the dark angle and here's this dark angle here. So that means the 6 corresponds with the Y because they're both across of that angle. And then last but not least, that would leave the 4 to correspond with the 10. If you're able to do it that way, great. If you need to redraw it, then please redraw it. So if I want to write my three ratios, 7 over x, 6 over y, and 4 over 10. Notice I'm continuously consistent with writing my proportions. 7, 6, and 4 are the three sides of one triangle, and x, y, and 10 are the three sides of the other triangle. This should not be mixed up. That is the most common error that happens when students are trying to set up similar, when they're setting up proportions for similar triangles, is that they end up putting, 7 over x and then 10 over 4. So it ends up being impossible to get the right answer because you've now mixed up the proportion and you were not consistent. So to solve for x, I'm going to use 7 over x. Now, I cannot use the 6 over y in this case because it's another variable, so I'm stuck with using 4 over 10. So I get 4x equals 70, and then 70 divided by 4 is 17.5. And there you go. Am I allowed to get decimals? Sure. I still have to solve for y now, so I need to use the fraction or the ratio that has a y, and then I always use any numbers they give me before using the ones I've solved for. That's always the case. And then 60 divided by 4 is 15. So now I've done a couple with you at the top. I also want you to recognize that in some of these examples, you will have to mark some vertical angles on your own, and that will help you. So for example, I'll do F with you. So if you see an F, we have some vertical angles, but then you should see we have parallel lines. So if we have parallel lines, that means I can make myself a Z. Now that Z is going to be really important because that means this angle and this angle are the congruent angles, or the alternate interior angles, which means that x plus 3 corresponds with 2x minus 8. That leaves me with 5 corresponding with 3. Notice how I only have 2 of the 3 sides. Is that okay? Absolutely. It's okay. You don't have to have all 3 sides if I've already told you the triangles are similar. So if I'm going to write this ratio, which I'll do right here, now I'm going to go from left triangle to right so I can stay consistent. X plus 3 over 2x minus 8 equals 5 over 3. Now that was very important that I stayed consistent when I wrote my proportion. Now, when I cross multiply, another important thing that you have to remember from algebra, if I'm cross multiplying a binomial with a monomial, I need to remember to distribute. It's 3 times x and 3 times 3. So this becomes 3x plus 9 equals 10x minus 40, okay? And then you need to continue doing the algebra here. So 9 equals 7x minus 40 because I subtracted over the 3. Then I add over the 40, I get 49 equals 7x. That means x equals 7. Now it asks me for BC. If I plug BC back in, I'm getting 2 times 7 minus 8. So 2 times 7 is 14, minus 8 means BC is 6. And then here I have 7 plus 3 because x is 7. So 7 plus 3 is 10. So there are your answers to F. So again, pause where you need to. Try some of these top problems. I'm going to just go over one more example before I give you the rest of the answers. And that one more example is here, letter G. Okay, notice where the 2 triangles are. So here's one of the triangles. And then the other triangle is the whole thing. Now that's super important so that you get the correct corresponding parts here. And I'm going to do my very best to help you see it. Now, in these examples, oh, I didn't even draw this straight when I drew this picture. Okay, so I guess that's going to make it a little challenging for me to, there we go. I guess that's good enough. I apologize. So if I want to draw these 2 triangles separate, that is really going to help me with labeling the correct parts. So my smaller triangle is AEB. Okay, and my larger triangle, which if I just copy and paste this, and I make it a little larger, and I make it green, I can label it triangle ADC. So in the picture, it's hard to see what corresponds, but if I focus on labeling everything that I know about each triangle, then I should be set. Now, in these 2 triangles, I only know the left and the right sides. I don't know the bottom, so I'll only be setting up, 2 ratios, not all 3. But here's the thing. If I know this whole thing is 8, and this piece is 5, how long does this need to be so that the whole thing is 8? Hopefully some of you are saying 3. So that's the distance from A to E. So I can come over here and be like, hey, this is 3. Then I know the right-hand side from this picture, from A to B, is x plus 2. Then I know from A to D, so the whole thing is 8. So I can come over here and say, hey, this whole thing is 8. But now here's something interesting. I need to know the whole thing here. What do I do with both of these 2? Well, for these 2, I had to add them to get a total of 8. So for these 2, I have to add them. If I add them together, I have to do x plus 2 plus 6, which is just x plus 8. So that's what this is, x plus 8. And that is how you find the missing parts of overlapping triangles, or you actually at least label them. Excuse me. So now, the left side should correspond with this left side, and the right side with this right side. So 3 over 8 should correspond with x plus 2 over x plus 8. Now I can solve, no problem. So I get 3x plus 24 equals 8x plus 16. And then I can subtract over the 3x. I get 24 equals 5x plus 16. And then subtract over the 16. So when I do 24 minus 16, I get 8. And then divide by 5. And when you divide by 5, you get either 1.6, or some of you might leave it, as 8/5. Either answer is acceptable because they're both equivalent. Then it says find the length of AB. Now AB is x plus 2. So I have to do 1.6 plus 2. And when I do that, I get 3.6. Now you can write it as a decimal, or you can write it as a fraction, which is 18/5. But again, you don't have to write the fraction. The only time you have to write the fraction is if the decimal is a long number that goes on and doesn't repeat, and it's so weird. So what you should do is, if it's a very long decimal, write it as a fraction. If it's a short decimal, write it as a decimal. I mean, it's up to you, but that's my preference. So here are the rest of the examples. See if you can complete them. Pause where you need to, and when you come back, I should have all the answers ready for you. So here are the answers. If you would like to pause the video whenever you need to. Letter L was the only time that I actually had to plug back in X before I could solve for Y. So I'm actually going to zoom in so that you can check your answers. We did A together. We did B together. Here's C. We did F together. Here's E. Here's D. We did G together. Here's H. Here's I. Here's L. Here's K. And then here's J. So pause it at whichever number you needed to pause it. All the answers are here. Hopefully you now understand how to solve for a missing part of similar triangles. If you have any questions, let me know. Again, have a great day.